Hey ninjas! Today we'll cover 3 powerful function topics that separate average code from elegant, maintainable code. First, we'll remind ourselves that functions are first class in JavaScript. Then we'll explore generators, functions that can pause and resume, and finish with currying, a functional pattern that makes code composable and reusable. All examples will run in code and run. Let's dive in. Before we get into generators and currying, let's ground ourselves. JavaScript functions are first-class values. They can be stored, passed, returned, and composed. This enables higher-order functions, closures, and the patterns we'll use later. Let's begin by storing a function in a variable and then calling it from that variable. This proves that functions are values in JavaScript. We assigned the function greet to say hello. Both names reference the same function object. Functions are values. Now, let's see how we can pass a function as an argument to another function. This allows us to abstract behavior, the foundation of functional utilities like map, filter, and reduce. We implemented a small map to show passing a function as an argument. This pattern underlies array.prototype.map and many higher-order utilities. Now we'll return a function from another function, a pattern often called a factory function. This showcases how closures work. Functions can return functions. MakeGetter creates a new function that remembers this uses closures and will be important for currying. Functions can also be stored in arrays or objects. Let's look at that. Functions can live in arrays, objects, maps, anywhere. Function identity matters. Functions are compared by reference. Quick recap. Store, pass, return functions. Compose and reuse behavior. Foundation for generators and currying. Generators let functions pause and resume. They're perfect for building lazy sequences, custom iterators, and controlled flows. We'll start simple and then explore advanced behaviors like yield asterisk, error injection, and cleanup. Let's start simple: a generator that yields 3 numbers, one by one. A generator function returns an iterator. Each .next resumes execution until the next yield. When done, done is true and value is undefined unless you return something. Instead of calling .next manually, you can iterate with for of, which automatically handles the generator. Generators are iterable. For of consumes them until done. This is a convenient, idiomatic pattern. Here's a generator that never ends. It produces an infinite sequence of IDs. This generator can produce an infinite sequence while only computing values on demand. Use it to lazily process potentially unbounded streams without allocating huge arrays. Generators can delegate control to another generator using yield star. Yield asterisk delegates to another iterable. It flattens nested generators or iterables into the current generator. You can also return a final value from a generator. A return provides the final value and sets done true. Note: 4. Of ignores the return value, it only iterates yielded values. You can inject errors into a generator using .throw, helpful for cancellations or error propagation. You can inject errors into a running generator using .throw. The generator can catch the error internally and clean up in finally blocks. This is useful for cancellation semantics or cooperative error handling. Calling .return tells the generator to stop and run its cleanup. Iterator.return signals the generator to finish and run any finally cleanup. This pattern is useful to free resources when stopping iteration early. Generators have historically been used to manage async flows, yielding promises, before async/await. Libraries like Co used this. Modern code uses async/await, but you may still see generator-based coroutines. Advanced users can also use async generator, async function asterisk, with for await of for asynchronous iteration. Quick recap. Function asterisk plus yield. Pause/resume. .next, .throw, .return, for control. Yield asterisk to delegate. Use for lazy sequences, iterators, and cleanup. Now we switch to currying, a functional transform that turns multi-argument functions into chains of single-argument functions. Currying helps build partial applications and composable pipelines. Let's first see the normal function, and then how we transform it into a curried version. Normal function. Currying transforms it into nested single-arg functions. Curried add, 2, returns a function that expects B, closures remember A. Partial application fixes some arguments ahead of time. Currying naturally enables this. Partial application binds some arguments. Currying is a way to produce partial application naturally. Bind is another tool, but currying leads to clearer functional composition. Let's build our own curry utility that can transform any function into a curried version. A generic curry checks if enough args were supplied, fn length, otherwise returns a function collecting more args. This supports flexible calling styles, fully or partially applied. Some functions are variadic, accept any number of args. Currying by arity relies on fn length. For variadic functions we can design APIs that collect until an explicit terminator is provided. Autocurry for variadic functions often needs a convention for when to stop collecting arguments, e.g., an empty call or special terminator. Use with care. Let's see where currying shines in real-world code, factories, utilities, and composition. This makes specialized functions easily. Curried helpers produce composable utilities, map with returns a function that expects an array. Currying plus memoization yields flexible caching strategies for partially applied functions, very powerful in functional pipelines. Currying increases function objects. Be aware of performance/memory if creating too many per instance. Prefer explicit APIs for clarity, don't curry everything blindly. Use curry where it increases readability or enables partial application reuse. Be careful with this, curried functions often lose this context. Use arrow functions or .bind as needed. Finally, let's combine what we've learned, generators and curried functions together. Here we used a generator as the source and a curried map processor. This demonstrates how these techniques compose beautifully. Generators provide sources, curried functions supply reusable transforms. Today you saw how functions being first-class unlock powerful patterns, how generators give you fine-grained control over execution and memory, and how currying transforms functions into reusable building blocks. Practice the exercises, come back with questions, and keep sharpening your ninja skills. Do the exercises, https://javascriptninjas.com/learn/chapter/27. Replace with your actual chapter slug if different.